welcome back to this project that we're doing here in our Common Lisp videos. I left off our last video with a bit of a challenge for you to see if you could implement the increment and decrement operators that are required for some of the work that we're going to be doing a little bit later in this series, and I hope that you came to a solution for them. However, if you haven't, we're going to implement those in this video, and we're going to implement jumps. But before we get into that, just a little reminder that I do have a competition running on GitHub. It's been running all of Halloween. You've still got a couple of weeks to get in for it if you want. The link will be in the video description below. But all that being said, we'll get right into solving these increment and decrement functions. So the first thing we want to do is get our number, which will be the nth. What am I doing? Nth. Well, I'm just sitting here blanking. I actually had this solution just a moment ago, and I can't remember what I was doing with it. So we want to get 1 plus a program counter. There we go. Please do forgive me, I have had such a crazy day. I almost locked myself out taking out the trash, so not my best of days. There we go. Sorry about that. So that's just basically looping forever, which is not what we want, but we can see that we're getting a 1 back, which is that. So that is our value. So we know that that's working. What we then want to do is update the value in that position. So what we want to do is say set f, and then we want to say nth num program, say nth actually that might be more convoluted than I intend, but say set f PC plus 2 PC, because it's 2 arguments, so we want to take, well, it's 1 argument, so we want 1 plus the name of the function, which is 105. So we will add 2 on here. So we've actually got this working now. I'm going to try this with 0. Something isn't quite going on right here, so this is a little bit weird. That's what I would expect. There we go. So this is behaving as expected in all cases. So we test to see if our program counter is 105, and if so, we get the number by getting the next argument in the list, which is this. Then we use setf to get the nth of the number of the program, so we look up the address here, which happens to be 1, and then we increment whatever that is by 1, and then we move the program counter on. And we basically do exactly the same for decrement. The only difference is instead of 1 plus, it's 1 minus. So with that in place now, we run that, we get 10620. So our increment and decrement functions are now working exactly the way that we want them to. So that's kind of cool. Now, the next thing we're going to implement is like a jump. It's like a goto. And so we're going to add this here, and because this is an entirely new class of logic flow, it's not arithmetic, I'm going to call this a 201. So we know that a 201 is an unconditional jump, and it's going to look like this. I just want to check something. Okay. It's going to look like this. We're going to do a 2. So this is going to be 6. There we go. So we want to take this 201 and 6 and jump to the 6th position, which is the start of this arithmetic thing here, this 101, which is our add. So let's take this line, because that will, you know, look up what we're starting with. You know, we want to get our first number, and all we're really going to do is we're going to not do this actually. We're just going to set the program counter to not 2 on. We're going to read the next thing on, which we've already done with num, and we're just going to set the program counter to that. So if we evaluate this now and run it, 201 6 28 45 101 1230. So we're going to add 6 and 2 together and store in the third thing 3. So we get our 6, our 2, and our 8, and we get our 4, 5. So this is actually working exactly as expected. We have our unconditional jump, all with this thing here. So this is a bit like our goto that you might have seen in older languages, you know, like BASIC or something like that, where you can go to somewhere. And that was surprisingly easy to implement, because all we do is we're reading a number and just setting the program counter to that. Now the next thing that we might want to have a look at here is a conditional jump. And that will jump to one location under a certain condition, otherwise it will jump to another condition. And if that sounds kind of familiar to you, that's little more than an if and an else. So here we've implemented a goto. Now we're going to implement an if. which again can be thought of as like a conditional goto. And we're going to call this a 202. And the way I'm thinking this will work is we are going to, what do we want to do? The way I think this should work is that if there is a 0 or 1, so we're just going to have this very Boolean. So we're going to give it an address, and let's make this slightly simpler. If there is a 0 in the address that is not, any other value will be treated as true. So we'll kind of put this truthy, falsy-ish kind of thing. So unless it is a 0, it will go to the first branch, otherwise it will go to the second. So we are going to jump, we are going to check an address. So we're going to add this on here. 6, 7, 8, 9, 10. So this is going to be 11. So what 201 is going to do is check the value of 11, which is this thing, and if it is anything other than a 0, it's going to jump here, otherwise it's going to jump here and run that. So you can think of this as like a function, almost. This sub part of the list is like a subroutine, and this part here is like another subroutine. So we're going to conditionally call one chunk of code or another chunk of code. So with that in place, we've got our 202, and I'm just going to change that to be 202. We're going to figure this out. So let's copy this, and we are going to have an if check. So if so again, all we're really doing is we're changing the program counter, because this is just a goto, so we'll get rid of that. There we go. So we've not quite got this right yet, because we need to actually set up the correct gotos, and that's fine. But we've got everything in place here. So if the number looked up by nth num program, after we've got that, so after the value stored in 11, after we've looked up the value stored in 11, if it is 0, we will jump to the position in 12, otherwise we will go to 6. Now let's invert this, just so it's abundantly clear that we're checking that it's not 0 is what we're principally caring about. So then we want to say nth, actually no, we don't. Here we do nth, plus 2 PC program. No, not PC, num. Yeah, I think that's what we want. So we're here 0, 1, 2. So this would become 3. Not quite. So why is that not the case? Let's just do a little bit of digging. Okay, so we need to look something up because we're getting 0, 1, 2, and so we need to get the value stored into. That's what we need to do. I'm always forgetting the nesting that you have to do here, so let's try this again. It still won't work yet because I'm just testing the output. But we got 6 and 12, so yes, this is indeed what we want. So let's get rid of that and that. And we'll copy that. And that, and just get rid of these 2 lines because that should be it working now. There we go. So at the bottom we have our 202, 18, 6, 12, 45, 101, 123, 0, 0, 101, 3210. And what I'm going to do is I'm going to make sure that we change a copy of that to 1. So this is 202, 11, 6, 17. 4, 5, 101. So what does the first one do? The first one checks position 11, and if it is not 0, it will jump to 6. So 101 will add the value stored in 1, which is 11, with the value stored in 2, which is 6, and store it in 3. So this should be 202, 11, 6, 17, which is not right. Oh no, this one jumps to 12, so 12 is 101, 3, so it gets the value stored in 3, which is, so that's 12, plus the value in 2, which is 6, so that's 18, yeah, and store it in 1, so that is correct. I just got my order the wrong way around there. So what we actually want to see on the second line, that would be 101, 123, so we're going to take 11, we're going to add 6 to it, and we're going to store it in 3, so that should be 17 here where 12 is. So let's just check that, and indeed 17 is where 12 is. So we are able to now see that our jumping has worked. We've got a very simple goto here, and we have an if or an else that have been implemented here in these functions here. I've not figured out how to do an elif, but it's not really important here. That's just syntactic sugar around some of the stuff that we care about. So next week we're going to look at equality operators. So we need to add things like equals to, greater than, less than, less than, equal to, and add some of these operators in place. Because with those we can actually start creating loops, believe it or not. But there we go. That is just our goto and our if else. No challenge for you this week because we just wanted to get these in place to add the next little bit to your Turing machine. But I hope that has been interesting for you. I hope you're following along at home and you've got the next bit in place. Again, quick last plug, there is a competition. I've got a copy of How to Build Games in Common Lisp. I'd really love it if one of you went home with a book, especially in 2020. If not, I guess I will just randomly pick someone, but I would really prefer it if you enter the competition just because they're fun. But hey, thanks for watching. Thank you for supporting my channel. Take care, everyone. Look after yourselves, and I will see you in the next video.